So, good evening, ladies and gentlemen and cats, and any children that might be there. Welcome to the end of season for the Astronomical Society of Edinburgh. And we're going to go out in a bang with Mark doing the sky for August. And then we're going to summarize some of the things we've done. And then we're going to talk about what's coming up. And basically, we're having a break for August, except Mark's not. He's going to run the imaging group all through August. And then
I thought you run that, Peter.
We have imaging group on the 12th of August. And our first meeting in September is the fast radio bursts and evolving cosmic, not comic, mystery. And I'm really looking forward to that. I think that'll be a really interesting talk because it is real hot stuff. So that's what's coming up. And tonight we're going to start with Mark doing the sky in August, and then we're going to go on to a summary of basically catching up on what we've done, and more importantly, listening to you guys and seeing what you think we should be doing, or we've done wrong, or preferably done right. And then what you'd like to see in the next session, the next year. So with that, I'm going to hand over to Mark so you can do the sky in August, and then I'll talk to you later. Thanks, Mark.
And we can have some questions at the end, and Alan will answer them for you. Because I won't know them. Okay, sky in August. Good start. Okay, well, I'll start with Comet Neowise, since that's been the star of the last month. It is now fading, but fortunately for us, it didn't fizzle out like Atlas and Swan did, so they put on a really great display. And I think it's fair to say that everyone and their dog, sorry, Nigel, and their cats photographed it. We had loads of images of it. Has a 5-kilometer wide nucleus, was last here 4,500 years ago, and it won't be back for another 6,800 years, so don't hold your breath on that one. This is from the start of the month to the end of the month, so it's heading west and heading lower down. It's approximately something like magnitude 9 now, and going to be about magnitude 15 by the end of the month, so fading very rapidly as it heads out the solar system. But you'll still be able to find it at the moment with binoculars or a telescope, probably just about, if you know where to look. But it's nothing like as grand as it was a few weeks ago. So here's the orbit of Neowise. It was at perihelion, the closest point to the sun, on the 3rd of July, 27 million miles away from it. And it was closest to Earth on the 23rd of July. But by the middle of September, it will be beyond the orbit of Mars and heading out for another long time. So, as I said, everyone's imaged it, I think, and we've had some really good ones from members. So I'll just put one up from everyone who's posted on the Flickr group. If I've missed anyone or forgotten one, I do apologize. I thought I'd got everyone, but you never know. There's David Small's one. John knows one from town. James Coburn's one, also fighting light pollution, but coming through that really well. Ian managed to get the comet far left and noctilucent clouds. It's really nice. Actually looks like somewhere from Africa, that, I think. And Fran similarly had the comet, and to the right, there's a bit of noctilucent cloud in there as well. Brave leader Andrew Farrow has taken it all lying down and is leading the way with lying in bed and doing astronomy. He did that from his bedroom window, lying down, I believe. I think that's a telescopic one from Ian. Yeah, very nice. And we'll take that one from the centre of town, I believe. That's my telescopic one. That's only a half-degree field of view, so it really is quite close to the head of the comet, that one. Ken Thomas had that one. And finally, Peter has that one. All really nice images. Okay, August is an important month because we finally get some darkness back again. So on the 9th of August, we will finally get some astronomical darkness when the sun is more than 18 degrees below the horizon for the grand total of 44 minutes, the 9th and 10th of August. On the 12th of August, an important date because that's when the maximum of the Perseid meteor shower is, we'll get a bit longer. It'll be astronomical darkness from about 23 minutes past midnight. But nautical darkness begins about 20 to 11, and you can start observing the meteors from then, and a bit more in a moment about that. And for the Perseids, the moon is being very, very kind to us. It's waning, and it's pretty small, and rises quite late on. So the actual peak of the Perseid meteor shower is in the daytime on the 12th of August. So the best nights are the 11th to 12th or the 12th to the 13th. The 12th to the 13th is the one that's normally the best. Under ideal conditions, skies and the radiant being overhead, you could potentially see over 80 meters an hour. For us, around about midnight, if we're lucky, we might see up to about 50 meters an hour. As I said, the moon is pretty favorable. It rises just before midnight and is only 42%. So we'll have a few hours where it doesn't really interfere too much. So my advice is find a nice reclining chair, lie back and look up and enjoy the view. If you don't have a reclining chair, then you'll get a sore neck. So that certainly helps. And you don't need any equipment, just your eyes. I usually quite like having a pair of binoculars with me so I can scan along the Milky Way at the same time, just for fun. And if you want to image them, then there's an article on our website on how to do that. So the radiant of the Perseid meteor shower is, as you might imagine, in Perseus. The meteors will appear to come from that point. They won't originate at that point. So if you see a meteor, trace the line of it back, and if it originates somewhere in Perseus, then it's probably a Perseid meteor shower. Meteors that are closest to the radiant tend to have shorter trains, and the ones further away tend to be longer as well. So conventional wisdom says that you shouldn't look directly at the radiant, but around 30 or 40 degrees away from the radiant. I always find looking over at Cygnus and Lyra and Altair, that's a nice place to look anyway, and it's high up in the sky at that time of night as well. So this is midnight on the 12th to 13th of August. And hopefully that way you'll see the most meteors you can. While you're lying back looking up, if you have a pair of binoculars, then very close to the radiant is a nice double cluster between Perseus and Cassiopeia. It's one of our ASE 24 objects, a really nice object in binoculars or a small telescope, and definitely want to look at if you get the chance. So the moon, as I said, is good for meteor shower. We start with a full moon on the 3rd, and it's an almost full moon at the end of the month. So new moon around about the 19th. So if you're doing any long exposure deep sky imaging, aim for the middle of the month this time, so you're not interfering, the moon's not interfering with what you're doing. These are a couple of pictures from Will Joy. Those are taken just with a fixed camera on a tripod with a zoom lens. One of them obviously in the daytime or twilight anyway. I think they show up quite a nice amount of detail. And those are on our Flickr pages. If you're into the moon or you're starting out, then the moon's a good place to start. And the first 4 objects in our ASE 24 are lunar features. You'll find that on our website, and some of the major seas and craters and other interesting features are on there as well. And it's a good place to start, and really useful if you've got a small telescope or a larger telescope, but all should be visible with the small telescope. And if you're a bit more advanced and you want to do a project on the moon, then there's the Lunar 100. Again, that's on our website. It's a list of the most interesting features on the moon, numbered from the easiest, number 1, which is the moon itself, I believe, to 100, which is something Genius, is that right? On the limb of the moon that you can only see when libration allows. Well, that's not libation, Peter, that's libration. If you want to image the moon, then 2 of our Intro to Astro Imaging courses have videos on that. The first one and the third one. The first one will show you how to do simple imaging using a camera on a fixed tripod, as Will had done, or through a telescope with single images. And the third one shows you more advanced techniques on high resolution lunar video. So have a look at those if you want to on our YouTube channel. Okay, the planets this month. This is how the planets look in the middle of the month. This is quite a nice representation. If you haven't been to the website intosky.org, it's got massive amounts of useful information such as this. I think the guy who creates the site is actually the webmaster of the British Astronomical Association, and it's really good stuff on there. So Jupiter and Saturn, you may have seen really low down in the south late at night. They really are low down at 11 degrees and 12 degrees, and it really isn't a good year at all for Jupiter and Saturn. Next year, you can see that Jupiter itself starts to climb a little bit higher, so it gets better, and the year after, it's starting to get a reasonable altitude. And the reason that matters is these were my attempts at imaging Jupiter and Saturn just last week, and as the ACE planetary imager Damien Peach says, it's like imaging from the bottom of a swimming pool. So you can just about make out a couple of the belts on Jupiter and just about the Great Red Spot. And Saturn has rings, and that's about it, really. For comparison, that's the sort of image I can take with that equipment on years when Jupiter is at a reasonable altitude. So you can see it does make quite a big difference. Venus is a morning object. It's emerging from the sun, rising about 3 hours before the sun by middle of the month. But it is rushing away from us now, so it'll be getting smaller and further away, but it's quite high up in the sky. So if you're into Venus, then you need to get up early in the morning to have a look at that. But the star for the rest of the year is going to be Mars, I think. It reaches perihelion, the closest point to the sun, on the 3rd of August, and opposition on the 20th of October. That's when it's directly opposite the sun as seen from us. By mid-month, it's rising about 11:30 and reaching a reasonable altitude later on to about 34 degrees. So that should be okay for observing and imaging. So I think it's probably the best planet for observing for the rest of this year, unless you're into Uranus and Neptune, and they're much fainter and you see less on them. So this is the orbit of Mars. We're currently trying to catch up with Mars. You can see as we move it on a little bit, we're getting closer to Mars. By the 1st of October, we're almost there. And the 20th of October, Mars is in a direct line with the Earth and the Sun. So that is when it should be really good. And of course, you probably all know that July has been a very important month for Mars. It's going to get a lot of visitors early next year. So the United Arab Emirates has launched their Hope orbiter successfully on a Japanese rocket. It was Japanese, wasn't it? Yes. China has launched an orbiter and a lander. And yesterday, NASA launched its Perseverance rover and a little helicopter to test out how that will work on Mars. So I think by February they should be arriving. So there'll be a lot of news from Mars after that time, I think. These are the relative sizes of the planets seen through telescopes. They won't look at anything like as good as that through your telescopes. Jupiter, obviously the largest, the king of the planets, at 46 seconds of arc, and very bright at -2.7. Saturn, the globe of Saturn, quite a lot smaller at 18 seconds, but with the rings, it's not far off the diameter of Jupiter. Venus at 23 seconds of arc and bright at -4.3. It will be getting smaller, but the phase will be increasing as it goes around to the back of the sun from us. And Mars middle of the month is around about 16 seconds of arc and -1.4. For comparison, though, when we get to opposition, it's going to be quite a bit bigger and quite a bit brighter. So the size of it is going to be something similar to the globe of Saturn, a bit bigger than that, and similar to Venus, and also almost as bright as Jupiter is at the moment. So you can see it's quite a big change between now and opposition. So I'm definitely looking forward to what we can see on Mars. And National Astronomy Week this year is going to be focused, pun intended, on Mars in November. So we will be talking more about that later on, I think. Looking to the night sky, looking south around about midnight on the 2nd of August, there's a nice conjunction of Jupiter and the Moon, and Saturn not very far away. Given how low Jupiter is, it's quite amazing that the Moon actually ever goes that low, but it does. So that could be quite an interesting view there. And the Moon is almost full at that point. Let's go to the night sky. So looking south on the 15th of August, I'll pick out a few of the signposts that we're quite familiar with. The Summer Triangle, the bright star Deneb, Vega, and Altair in Cygnus, Lyra, and Aquila. That's the most famous one. And then Square of Pegasus. That projection makes it look slightly squint, but I think it is actually squarer than that when you see it in the night sky. And the one I quite like to use if I'm looking for constellations further west is the Keystone of Hercules there. It's not as bright as the other two, but I still think it's quite distinctive shape and useful for finding certain objects. So if you can find these signposts, then you can usually find objects within them or around about them or the other constellations, and I think they're quite useful. And Acute 1 Delphinus, a little dolphin, it doesn't stand out very strongly, but it is quite a definitive shape and quite a nice one, I think. So I thought I'd dig into the Summer Triangle a little bit more. I've never really thought too much about it other than there are 3 bright stars that we can pick out, but they're obviously not associated with each other. In fact, most of the stars and constellations are not associated with each other. They're usually just line of sight effects. So I thought I'd do a little bit of digging. So Vega, the brightest of the 3, is 25 light years away and almost exactly magnitude 0. Altair is a little bit closer at 16 light years away and a little bit fainter, and the faintest, Deneb, is actually at 2,600 light years away, so dramatically further away. So what that actually means is, if that's the sun at the bottom, Altair is about 1.6 times the size of the sun. Vega, the slightly bluish star, is 2.3 times the size of the sun. And you know what's coming with Deneb. Deneb is over 200 times the size of the sun, a bluish white giant star. So it sort of puts it in perspective slightly there. Vega itself is a very interesting object. I didn't know this, but it rotates so fast, about 274 kilometers a second, that it bulges at the equator. So I think it's actually about 18% wider than it is tall. It's dramatically squashed. Jupiter rotates fast and it is flattened at the poles, but nothing like as much as Vega, and that's in comparison to our sun up there. And because of the way the Earth wobbles on its axis, it used to be a pole star in about 12,000 BC, and a much nicer pole star to have it would have been than our current faint Polaris. And if we wait for another 13,000 years, it will be the pole star again. Vega has a circumstellar disk, so it's possible that protoplanets are forming there, and that's an infrared image of the disk debris there as well. I don't think it's as blue as that in reality, but it's certainly you can certainly glimpse the blueness when you look at it through a telescope. Okay, so interesting objects in the skies at the moment. Again, these charts are all for about the middle of the month, so you can adjust them for a few days before, a few days afterwards. The difference won't be that great. The best globular cluster in the northern hemisphere, the largest, brightest, is M13 in Hercules. So the Keystone signpost is useful for finding that, about 22,000 light years away, and right on the very edge of naked eye visibility. You probably need binoculars to see that, really. and quite large at 20 arc minutes. For comparison, the moon is about 30 arc minutes, so it's pretty large, but nothing like as bright. And not much fainter or smaller. M15 in Pegasus over there as well, just slightly fainter, slightly smaller. So these globular clusters exist in a halo surrounding the galaxy. They're away from the plane of the galaxy in a halo around about it, and there are about 150 of them known. If you're into double stars, then there are quite a few interesting ones around here. The most famous one we all know about is Albario, right at the very head of the swan. It's not a true binary. The two parts of it are actually about 60 light years apart. But visually in your telescope, they are separated quite widely at 34 seconds of arc. So you could probably separate those with binoculars, and any small telescope will separate those. And it's a very beautiful color combination of orange and blue. Slightly less well-known, Gamma Delphini, right on the nose of the dolphin. It is a binary system, and it's got an orange subgiant and a yellow-white dwarf. Closer together, you probably need a small telescope to separate those stars. And another famous one, the Epsilon Lyrae double-double. So widely spaced, two stars, but each of those stars again is a binary star, and those separations over about 2 seconds of arc. You will need a good telescope to see those. A small telescope will possibly show you that they aren't single stars, but a bigger telescope will help separate them more. While we're in the area, there's a nice open cluster M39. It's not a very rich cluster, but the thing I like about this one is there's a few really bright stars, but they sit on a nice background carpet of the Milky Way, so it gives you a sort of sense of depth. And I think the stars of the cluster are much closer to us than the background stars of the Milky Way, so I think it stands out quite well. And these are often called galactic clusters because they do exist. Open clusters do exist normally within the plane of the galaxy itself. So globular clusters exist in the halo surrounding it, and open clusters tend to exist in the galactic plane. Zooming in a little bit further, for you imagers out there, I'm an imager, so that's why I'm doing this. The Cocoon Nebula up at the tail end of Cygnus. This is something the HOIS project has been looking at recently, and the three people doing the HOIS LCO telescopes have been imaging this. So this is a young star-forming region where a lot of the stars are in areas of gas and dusk, and the light curves show that they are getting brighter and fainter as the dust goes in front of them or clears away from them. But it's quite an interesting region, that one. Another one for the images on the wing of the swan is the Veil Nebula. It's in several parts. The two brighter parts are the Eastern Veil, which is this one here, and the Western Veil is often called Witch's Broomstick, I believe, because it looks like that. And these are the remnants of a supernova, quite widely spaced. And right at the very tail of the swan, there's the Pelican and the North America nebulae. The Pelican Nebula, again, is one of the HOIS objects and is a strong star-forming region, and quite a lot of objects in there that vary in brightness as they're being formed. And protoplanets are being formed that sometimes pass in front of these stars and cause light curve dips. So lots to image in around that area. Okay, if we head to the northern sky now, also around about the middle of the month, the obvious pointer that everyone knows about is Ursa Major, pointing to the pole star. But a couple of other constellations I wanted to look into. The W of Cassiopeia, we all know well, it stands out very, very well, but also Cepheus, which is far less obvious, but quite an interesting constellation in its own right. So we zoom in a little bit on those. So pick out a few open clusters, M103, one of the Messier objects, down in Cassiopeia, quite nice. Interesting color combinations in some of the stars. A fainter one, much harder to find, White Rose Cluster, or Caroline's Rose Cluster as it's called. That was discovered by Caroline Herschel, the sister of more famous astronomer William Herschel. but she was also a talented astronomer in her own right and discovered lots of stuff herself. Bit fainter. You'll be able to detect both of these in binoculars, but the Rose cluster, you might need a telescope, a small telescope, to see more about that. M52 also at the top of Cassiopeia, with the bonus of the Bubble Nebula. You can't quite make it out on there, but to the top right, there's the Bubble Nebula. If you're an imager, then this is something that you might be able to get. Strong in hydrogen alpha, you won't see that visually very easily at all. And it really does look like a soap bubble, but it's a shell of gas that's been thrown off the star at the center of that expanding gas shell. And one other cluster, which is one of my favorites, which is not so well known, is the Owl cluster. You can see the two bright stars at the top sort of look like eyes of an owl. Again, some nice color combinations in there. And that's object number 13 in the Caldwell catalog. And if you don't know what that is, that was the catalog that Patrick Moore created. He's Patrick Caldwell Moore, I believe. So these are objects that didn't make it into the Messier catalog. Some of them are very faint, and a lot of them are actually in the southern hemisphere. And for imagers, there's lots of nebulae in the area. In Cepheus, there's the Iris Nebula. You can see why it's called that. It's actually quite a tricky one to image, I think, because there's a lot of dust surrounding it, and it's very easy to process that out and lose it. But it's quite a nice one to look at, I think. The Wizard Nebula, I don't know if you can make out a wizard in there. I often struggle. In a strong hydrogen alpha region. It's also in Cepheus. And this is from Ian, the Elephant Trunk Nebula. This again is one of the Hoy's objects where there's a lot of, it's a strong star forming region as well. Lots of interesting objects in there as well. And these are all things that you need longer exposure imaging to capture. So these are really for the images. And that's it for now. So if anyone's got any questions about any of that, hopefully either I or Alan or Horst can answer.
Or we could put them on the chat for the moment, and then we'll come back. And thanks very much, Mark. Could everybody unmute and thank Mark for a very good presentation?
Absolutely. That's good.
Okay.